Hello students, welcome to the lecture of hydrocarbons. In the last lecture, we had discussed about the acidic nature of alkynes and we had started discussing about various reactions of alkynes. So, we had discussed that the acidic nature of alkynes is due to its hybridization, that is hybridization of the carbons. So, triple bonded carbon has the hybridization sp, which means 50% S character, whereas double bonded carbon had sp2 hybridization and 33.3% S character, whereas single bonded carbon were sp3 hybridized with 25% S character. So, we had seen that higher the percentage of S, higher will be the electronegativity. So, if the electronegativity of the carbon is higher, then it will attract the bonded electrons towards itself. So, it will be easy to break the CH bond. That is why, since the triple bonded carbon have the highest electronegativity, they attract the bond electrons towards themselves and the alkyne CH bond is the easiest to break. That is why alkynes possess acidic nature, that is very easily this CH bond of alkynes can be broken and a negative charge is formed. So, it is concluded that alkynes are acidic in nature. Now, alkynes like alkenes also undergo addition reactions. So, the first addition reaction we had discussed were hydrogenation. So, the mechanism of addition reaction for alkynes is same as that of the alkenes. So, at first a pi bond breaks, it captures the hydrogen. If this is HZ, then it will capture the hydrogen and hydrogen will be bonded to one carbon and the other carbon will develop a positive charge. Now, what happens in the next step, the anion that was formed will attack on the positively charged carbon and such addition products are formed. Now, they also follow Markovnikov rule, that is, this addition of the hydrogen will depend upon the stability of the carbocation. So, product formation depends on the stability of the vinylic cation. So, these cations where the carbocation is formed on a double bonded carbon, they are known as vinylic cation. So, the stability of the vinylic cation will decide the product formation for unsymmetrical alkenes by following the Markovnikov rule. For symmetrical alkenes, there is no difference. So, we had discussed about the hydrogenation of alkynes, which in the first step will form alkene and in the second step they will form alkanes, that is alkynes by one molecule of hydrogen will form alkenes and with two molecules of hydrogen they will form alkanes. And the mechanism of hydrogenation we had already discussed when we were studying alkanes and alkenes, that is there will be a metal surface and the reaction will occur by adsorption and desorption. Adsorption and desorption. Okay. Now, we will discuss the second type of addition, that is the addition of halogens. Okay. So, Let's take one alkyne. So we have taken propyne and we add bromine. Okay. So when we were studying the addition reactions of alkenes, we had discussed the mechanism that one bromine will have a partial positive charge and the other will have a partial negative charge. So there will be the formation of bromonium ion. How? So if this, so one pi bond breaks and it attacks on the positively charged bromine. So now there will be two bonds between these carbons and they will be bonded to the bromonium ion. Okay. Like this. Now what happens? There was another bromine which was in the form of Br minus. So Br minus will attack on this carbon and this bond breaks. So now we have this. We can call this as 1,2-dibromopropene. Okay. So this is one alkene. Now again if we add bromine, that is we don't have to add the second time. Whenever we are adding bromine, there is not a single molecule of bromine in that. There are multiple molecules. So now again this 1,2-dibromopropene will react with another molecule of bromine and again bromonium ion will form. Like this. So as we had discussed earlier, halogenation to double bond or triple bond is anti-addition. Okay, that is two bromine groups will be attached in opposite sides, that is opposite planes. So here also this was E, right? Here also if one bromine, let me write it in a proper way. So if one bromine is above the plane, the other one will be below the plane. So now the bromonium ion has been formed. So there is one Br minus, it will attack here and this bond will open. So we get this. We can write it like this. So we call it 1122 tetrabromopropane. Right? So 4 bromine atoms are attached to 2 carbons. So in this case also, like we had discussed in case of alkenes, the test for unsaturation. That is, initially bromine has a reddish orange color. After adding to the unsaturated compounds, what happens? It becomes colorless. After addition to unsaturated hydrocarbons, it becomes colorless. Because after addition reaction, bromine is no longer left in the Br2 form. It has been added to the unsaturated hydrocarbons. So, the reddish orange color of bromine disappears and it becomes colorless. So, test for unsaturation is applicable for both alkenes and alkynes. Okay. So, this was the halogenation of alkynes. The next reaction is addition of hydrogen halides. Okay. So, this is an alkyne and we will take hydrogen halide, that is HCl, HBr, HI, etc. Right. So, let us take HBr. Now, one pi bond will break and it will capture hydrogen. So, again vinylic cation is formed. Okay. Now, this is a symmetrical alkyne, right? This is ethyne. Ethyne is a symmetrical alkyne. So, there will be no factor of the carbocation stability, because even if hydrogen is added on this carbon, the product will be the same. Now, there is Br minus in the system, it will attack here and we get this. Okay. So, this is bromoethene. Okay. Now, there is one more unsaturation left, that is once again addition reaction can happen. So, there is another molecule of HBr. Now, the Markovnikov and anti-Markovnikov rule will come into play. Why? Because at first it was a symmetrical alkyne. So, the both sides of the double bond were similar. So, the addition of hydrogen and bromine does not depend on which side the carbocation is more stable. But now, on one side of the double bond we have CHBr and on another side we have CH2. Now, when we add one more molecule of HBr, then Markovnikov rule will come into play. That is, the negative part will add onto that carbon which contains the less number of hydrogen. So, among these two carbons, it has one hydrogen and this has two hydrogen. So, now the negative part will add to the carbon having less hydrogen, that is bromine will add to this carbon since it has only one hydrogen. So, bromine will be added here and hydrogen will be added to this carbon. So, this becomes CH3. So, we will call it 1,1-dibromoethene. Okay. So, this is a geminal dihalide. Geminal dihalide. Okay. So, geminal means when two groups are attached to the same carbon. So, here both the bromine atoms are attached to the same carbon. So, we call it 1,1-dibromoethane, which is a geminal dihalide. Now, if we take propyne, okay, and we add HCl. We can have so either we can have this, or there is a second possibility, that is this. Okay. Now this carbocation is more stable and this is less stable. Since this is unsymmetrical alkyne, so it will follow Markovnikov rule. So unsymmetrical alkyne follows Markovnikov rule. Okay. Now we have Cl minus, so two products can be formed. Okay. So this will be the minor product and this will be the major product. Now since there is one more unsaturation left, so again HCl can react, and again what will happen, since this is the major product, this will react. So here we have 2 hydrogen and here we have no hydrogen. So naturally this hydrogen will be added to this carbon and chlorine will be added to this carbon. So we get okay. So this is 2,2-dichloropropane. This is again a geminal dihalide. Okay. So the next reaction is addition of water. Okay. So alkynes generally do not react with water, they react with water in presence of mercuric sulfate and sulfuric acid at 333 Kelvin. So does not react in general conditions. Okay. So at a higher temperature and in the presence of mercuric sulfate and sulfuric acid, alkynes react with water, alkynes plus water in the presence of Hg2 plus and H plus at 333 Kelvin give carbonyl compounds, that is aldehydes or ketones. So we will discuss in details about the addition of water to alkynes and other reactions of alkynes in the next lecture. Thank you.